Hello everyone. Good morning, beta. Then I hope you are fine. Now today we are starting our next topic of this unit, that is unit and dimension. Okay. In last class we have done about the quantity as unit, and today we will do dimension. What are the dimension and what is the need of the dimension? Then first our topic unit already we have done. Then the dimension we will do. Dimension means that is a power of the unit. Okay, we are writing then unit quantity of the different quantity. We are writing that, for example, force I am writing here, force. Then first we are using force. Then force is our quantity in our physics. Okay, force is a one quantity, then its unit we can write by using how we can write the unit in our physics. I told you, beta, if you know the formula of any quantity, then easily you can write the formula of the quantity. Okay, for example, force if I am writing here, then its formula equal to mass into acceleration. Then mass we can write there kg, acceleration we can write there meter per second square. Okay, then when we will keep this one in use formula, then it will be your SI unit of the force. We can say that is your ms unit. ms means meter kilogram second. This one SI unit of the force also, so that's why their unit is this one of the force. Like this one we can find another example. You can take with a momentum. Okay, but linear momentum, if we are talking about the linear motion, then momentum will be linear already. Motion can be a different type. Rotational if we are talking, then momentum will be angular momentum, but here linear momentum only. So that's why here for the momentum we know that is mass and your velocity. Okay, this one your momentum. So how we can write its unit? Mass kg unit, and velocity we can write there meter per second minus 1. Like this one we can find the unit of any quantity in our physics. Understood everyone? Any no, you don't know better unit of any term, first write the formula of that term, then write the fundamental units of that formula. Okay, then write this one according to formula, then your units will become. Now after this one, next topic our we will do dimension. If here you can find the unit, then by using unit how you can find the dimension of our different quantity. Okay, now next our dimension. What are the dimension? Dimension are the power of the fundamental unit or the present in the unit of the derived quantity. We have done in last class fundamental and the derived unit. Fundamental which can't be derived from the another unit. There are the 7 type of the fundamental unit, and next our derived unit that we can derive from the fundamental quantity. Okay, so your dimension are the power of the fundamental units that are the known as the dimension. For example, here for the dimension we are using, for the mass we will use dimension m. Okay, unit already you have done, beta. If you don't know, then again I am telling you, unit of this mass we can write there kg. But dimensionally if you want to write this mass, then in the keep in square bracket. Always use, beta, this one is the syntax to represent any dimension. Keep that one dimension in a square bracket. Okay, then inside this one we will write the capital M, not small m. That is capital M only that represent the mass. Okay, next for the length, then in the square bracket, then we will use capital L that denote the dimension of for the length. So unit of this one we can write there meter of the. Next our time. This one dimension of the time we will use capital T letter inside the square bracket, then it will represent the dimension of the time. And but unit of this time will be always second only. Next our current, how we can represent dimensionally? Capital A letter within square bracket, that will be represent your current. Its SI unit will be our ampere. Okay, capital A letter we can use AMP, ampere we can use. Next our topic is temperature. Temperature, for the temperature we are using capital K letter within square bracket. Then this one represent our temperature, and its unit will be our Kelvin only. Okay, amount of the substance, then mole only, MOL. In your square bracket, this one your dimensionally, and unit also will be your mole only. Okay, and its symbol will be MOL only. So next here luminous intensity, luminous intensity, one more left beta, luminous intensity, there CD, that will be dimensional formula of your luminous intensity, and here unit of this one will be your candela. What? Candela. Okay, these are the unit of the 7 fundamental units, and these are the dimensional formula of the fundamental unit. Okay, then how we can represent any quantity in form of the dimension formula? Then in next year we will write their, take their different way. For example, here you have to write the dimension formula of the following quantities. Here different quantities are given. Then how we can write the dimension formula? First I am telling you syntax of this one. Syntax of dimension formula of any quantity. Okay, first of all we will take square bracket, but we will take the square bracket, then inside the square bracket we will take M, L, T. Okay, M stands for the mass, what? Mass. L stands for the length, and T stands for the time. Clear to everyone? Okay. So if here some power will be there of mass, then here we will represent the power. Let here A power of the mass, and here length power will be there. For example, sphere, cube, like this one. Then B becomes a sphere and cube. And here will be power of time. There will be, let we are taking here C, that can be 1, 2, 3, like this one. Okay. So this one is a representation of our dimension formula of any quantity given. Then we can represent like this one. If any quantity not having mass, for example time, not having then their power, we will take their 0. And we know that if power is having 0 of any term, then we will take a 1 only. Okay. So now starting this quantity with an example, then here first one written here volume. Okay. Know about the volume, that is side into side into side. Okay. So here we can write there length, cube we can write there volume. Okay. Cube of the length, then we can write there volume, length into breadth into your height. Okay. So side into side we can write there. Here we can write the side cube, then we can write the side. Cube of the side, that side can be length, breadth and your height. Okay, so volume, that means side cube we can write there. Meter cube will be its SI unit. So SI unit if we can write, and dimensionally easy we can write here. Then dimension formula of this one M, L, T. First write like this. Okay, here if power of mass is given something, then we will write, otherwise we will write 0 only. So here mass is given. No, here meter only. That's why here we will take its value 0. Okay. Here length is having meter cube. That's why here write meter cube. Okay. Next one here T stands for here meter time. Here time is available, then we will write. Otherwise its power we will take 0 only. But 0 only. Clear to everyone? So this one is a dimension formula for the volume. Next our quantity. Next our quantity, our velocity. For the velocity, how we can write beta? That is here. Velocity we can write, you know about the velocity. Velocity is a displacement per unit time is known as the velocity. So a displacement per unit time we can write their displacement unit will be meter, per unit time will be your second square. Okay, so dimension formula, so not square beta, here will be meter per second. So here we can write, keep your square bracket first one, then here write M, L, T. Okay, check which term is given in your formula or not. Now here meter is given, meter is here for the length and here second for the time. Okay, so that's why here M stand for the mass not having kg in your formula. That's why here we will keep the power 1, because we know that if any term is power having 0, then we will write it 1 only. Okay, so here length will be 1 and your time will be minus 1. So this one is a dimension formula for the velocity. Clear to everyone? Like this only we will write the remaining quantity dimension formula. Acceleration, we know that SI unit of the acceleration meter per second square. Okay, so same as we will write for this one meter, that is mass will be 0 only. For the length, its length will be 1. For the time, that is square, then that's why here upper side then it will become minus 2. This one is a dimension formula of the acceleration. Same like as remaining quantity we will use for dimension formula. Newton beta, I told you previous also. Newton we can write there mass into acceleration. Okay, here beta acceleration is our derived unit. That's why first we will convert into fundamental units. How we can convert? First of all, that your mass force the kg and acceleration we can write there meter second minus 2. Clear? So how we can write its dimension formula here? Kg is there. That's why now we will not take its power 0, but this time we will take power 1. Now this one here for length 1 and for the time then we will take there minus 2. Okay. Now next our beta work done. First of all beta you can do these dimension formula only if you know the formula of this quantity, you know the unit of the quantities. Okay. First of all you have to learn the unit of these quantity. Okay. So work done, we know that work done that is equal to your force into your displacement. Yes or no? That is known as work done. Work done means if we are doing some applying some force on any object, what happened? Some displacement will be there. So work done we can say force into displacement. So unit how we can write in form of the fundamental terms. Then here force unit written already here. That is your kg meter second minus 2 and here will be your second only, that's why here we will write there displacement unit will be your meter. Okay, so here will be meter square, then dimension formula of this one m1 l2 t minus 2. This one is a dimension formula of the work done. Okay, same as it is your momentum and energy. Momentum we can write their unit kg meter second minus 1. This is the unit of the momentum. So compare this one with our dimensional syntax. Then how we can write there m1 l1 then t minus 1. This one is a dimension formula of the momentum. Okay. Next our energy. For the energy how we can write there energy beta anywhere, any type of the energy. There is in our nature different form of the energy acting. Okay, keep in mind one thing that energy always will store in form of the work done. Okay, anywhere you want to find the energy of any term, then energy always will be stored in form of the work done. You can find the work in that form. That work always will be equal to our energy only. So here we can write mathematically, then energy always will be equal to our work done only. Okay, so this one here work done only. Work done already we have done this one. Work done dimension formula will be here m1 l2 t minus 2. This one is our dimension formula for the energy. Clear to everyone? You can find dimension formula of any quantity using your unit only. Okay. Now next beta last one line written here, mathematical number are the dimension letter. Okay. In any formula, any mathematical written there, that they are the dimensionless. Clear to everyone? For example, that is your kinetic energy. Okay. For example, kinetic energy. Kinetic energy formula, we know that about this one, half mv square. Yes or no? In 9th class already we have done kinetic energy half mv square. If you are given that kinetic energy is half mv square, then m will be dimension, we can write the dimension, but here half left. This half is your mathematical term. So here written beta any mathematical number are given, then all are the dimensionless because they are the unitless. There is not having any unit of the any number 1, 2, 3, any number we are writing mathematically. So all are the dimensionless. Okay, now next our topic beta dimension analysis. In previous, that is there we have done how we can find the dimension of any term, then what is the need of the dimension, why we are writing units in form of the dimension. Yes, na? So these are the different application of the dimension. Here first one, if any equation is given, okay, we are doing the different equation in our physics, then these equation we are writing right or wrong. Okay, to check the equation, then this is right or wrong, then we are using dimension. Okay, if we first we will write the dimension of the each term, then we will check they are right or wrong. Then after this one we can check this equation is right or wrong. Now another application of this one, conversion of the unit. Conversion of the unit means we want to convert one system to the another system. We have done system of the units. There is a different system, that is here MKS. Yes or no? MKS means meter, kilogram, second. We have done CGS, centimeter, gram, second. We have done your PGS. Okay, pound, gram, second. Now here, foot, sorry. FPS, foot, pound, second. Okay, then there is a different use of this one. We can convert one system of the unit to the another system of the unit. For example, any term is given your CGS unit, then you want to convert into MKS SI unit, then we can use their dimension. Okay, another, that is third, that we can derive the relation. Okay, we don't know what is the relation between them, but you want to derive. Okay, any different quantities are given, then you want to find the relation between them, what is the relation, then we can use the dimension. So here first one beta conversion of the unit, their use of the dimension. Then first conversion of the unit, I told you that you want to convert one system to the another system, then we will use their dimension. Second, our to check the dimension consistency of the unit. Okay, means any equation written anywhere we are writing in exam also beta, any equation is written, then first of all we have to check that you are writing right or wrong. Okay, so to check the equation our right or wrong, then their both side, if one side will be Newton, then another side also will be Newton, one side will be meter, then another side also should be meter. So there also we are using our dimensional formula. Okay, third one, use derive the relation between the quantities. Derive the relation means if I am saying that is any object is moving here and there, then how much distance is traveled with what speed, then what is the relation between them, then to make the equation also we are using the dimension. Okay, these are the three applications for the dimension. Next our beta, one by one we will do these application, how we can solve this one. First one, your dimension analysis. Dimension analysis can be used for first one use, conversion of the unit. Okay, I told now we can use this one for the converting one system to the another system. Okay, here I told you beta, if I am writing here MKS unit and you want to convert into CGS unit. Clear? And if CGS unit is given, then you want to convert into MKS unit, one system to another system, then we are using dimension. So first one, use of the dimension, conversion of the unit. So how we can convert this one? Let here this one we are taking unit of this one system, then dimension formula for this one we are using U1, and for this one we are using dimension formula in form that is U2. Clear? So here syntax of this one, how we can convert this one, N1 U1 equal to your N2 U2. Clear? How this one written? N1 can be any number for any quantity. Okay, and U1, that is a one type of the system, and N2 the another number for the your another system of the unit, and U2 will be another system of our unit. Okay, so if here n1 will be given, then u1 will be, how we can write there for this one quantity in mks. Then first of all we will write their dimension formula for this one. How we can write m1 l1 t1 like this one. Okay, here we are taking the general formula of this one. That's why here we are taking a b c n. Okay, here we can write there for n2, then here we can write there m1 l1 dimension formula will be remain same beta for both quantity. That's why here we will write there a1 b2 c1. Clear? If you want to find out n1, then we will take this one side, then we can find the one quantity to the another quantity. Okay, next we are doing the for example, but you will understood with example. For example, here you want to convert 1 Newton to the dyne. But 1 Newton to the dyne. Here Newton, we know about this one. Newton is a MPS SI unit of the force. Okay, this one our force unit. What? Force unit. Okay, force. So we know about the force unit. First we will write the dimension formula of the force. As we know about this one dimension formula, first we can write their formula. If you don't remember your dimensional formula of the force, then first we can write their formula of the force. Okay, so first your formula of the force we can write there, then unit of this one mass kg, and acceleration unit we can write there meter second minus square. Here using this unit, then we can write the dimension formula of the force, that is here m1 l1 t minus 2. This is the dimension formula of our force. Okay, so here beta question is given, then you want to convert 1 Newton equal to how many dyne. Okay, Newton is our MKS unit, you can say SI unit of our force, but dyne is not SI unit. This one our CGS. What? CGS unit of the force. CGS unit of force. Clear? So now a question, you have to convert force SI unit into our CGS unit. So how we can convert? I told you general syntax we will write here n1 u1 here, n2 u2 we will write. Clear? Here given beta already 1 Newton equal to how many dyne. Okay, you have to find out 1 Newton equal to how many dyne. So let here we are taking n1 equal to given beta 1 only. Okay, 1 Newton. So u1 we can write their dimension formula for the Newton. Dimension formula for the Newton we can write there m1 l1 t minus 2 like this one. Clear? So here n2 you have to find out n2. Clear? Means 1 Newton equal to how many dynes, means n2 you have to find out. How you can find n2? So by using your mathematically, then n2 we can write there n1 u1 by u2. Yes or no? This one is the rule for the finding any equation. Then n2 like this one. Now put up the value of these following terms. Then here we can write there n1 equal to here 1 only, and u1 you can write there m2 m1, u2 you have to find out. Yes, u2. Then here m1 l1 t1. Okay, divide by here power will be a b c like this one. Here we will take there beta m2 a l2 b, and here t2 c we will take. Clear? Now here for this one we know about this one u1, that is our your Newton only, and here this one you have to convert into dyne. Then in the dyne we can write there about this one, then it will be your centimeter in CGS unit. C stand for the centimeter, G stand for the gram, S stand for the second. Okay, so we want to convert this one in form of the like this one, then we can write we will solve here. Here we can write better than and 2 equal to, that is equal to 1 only. So here we can write there. Then in CGS we can write there mass. How we can convert gram into your centimeter? Then thousand. Sorry, meter na first one length. Then we will take there first one stand for the length centimeter. Then we will convert meter into your centimeter. We want to convert beta meter into centimeter now. Then we will write there 1 meter equal to your 100 centimeter. Then here will be your A. A will be your its power 1. Then your next year for the mass, then mass will be your 1000 only. Next will be your second. Then here will be your 1 second. Okay, so here this one will be your for this one. Then m your gram meter centimeter second minus 1. So here we can write its power. Then here 10 raised to power square. Here we can write there 10 raised to power 3. Then here we will write there gram gram 10 square gram 1000 centimeter second. Then here will be this one second. Then here it will become beta 10 raised to power 5. Okay, so here we can write this one beta 1 Newton equal to 10 raised to power 5 dyne. Okay, like this one we will solve. Then how we can convert one system to the another system. Then we have converted 1 Newton equal to in CGS, then that is equal to 10 raised to power 5 only. Okay, now next year dimension analysis to check the dimension of the consistency of the equation. This is our second use of the dimension analysis. Here we have to check any equation is right or wrong. Okay, first one there, follow the principle of the homogeneity dimension to find the relation between these equations, that we have to check these are right or wrong. For example, if I am writing here kinetic energy is equal to half mv square, yes or no? If I am writing here kinetic energy is equal to then 1 by 2 m square v square, then your question is that then check that dimension, is this one dimension right or wrong? Okay, so there also we will use their second use of this one dimension. Okay, any another equation we are writing, then s equal to your ut plus your half at square. This is your second equation of the motion. Then here this one again you want to check this one dimension is right or wrong. Then here also then we will use their second use of the dimension. So here next your argument of the trigonometry logarithm, these functions should be a dimensionless, but a mathematically number always dimensionless, and these function also will be dimensionless. Then example of this one equation we will do later. Thank you.